All right, today we're going to dive into a research proposal that asks us to completely rethink the universe. It's this thing called the two-layer model of reality. And trust me, it suggests that at the heart of everything is an almost unbelievable simplicity.
So, let's just jump right in with the big, mind-bending question at the heart of this whole thing. Forget about particles, forget about forces, forget all the separate little pieces for a second, and just ask yourself, what if everything you see, everything you are, is fundamentally just one single continuous object?
Now, to really get how radical this is, you got to compare it to what we have now. The Standard Model of Physics is without a doubt one of the most successful theories ever, but it describes reality as being built from, well, a zoo of different fundamental particles and forces. This new model? It proposes something way, way simpler, that deep down there's only one thing.
Okay, so if the entire universe is just one thing, you're probably asking, what is that one thing, right? Well, let's dig into the foundation of this idea, what they're calling the fabric of reality.
So the big idea here is the single fabric of reality. And what's really crucial to get is that this isn't some background that things exist in. No. This fabric is everything. It's the whole show. The entire physical world, just one continuous whole object.
Okay, so what's this fabric like? Well, first off, it's a unified structure. It is, and I'm quoting here, one whole object. That's it. And it has these built-in properties, the most important one being elasticity. Think of it like a giant cosmic rubber sheet. And here's the real kicker. Particles, forces, they aren't separate things floating around on the fabric. They are the fabric. They're just vibrations, stresses, stable patterns happening within it.
And right there, you see the massive ambition of this whole project. The goal isn't to keep adding more complicated pieces to the physics puzzle. No, it's to start with the simplest thing imaginable, one single elastic object, and see if you can get all the mind-blowing complexity of our universe to just emerge from it.
But having a beautiful, simple idea is one thing. Having a theory of physics that actually works? That's a whole different ballgame. So now, let's talk about the ultimate test for this model, where it has to face off against one of the absolute weirdest rules in all of quantum mechanics.
Look, any new theory that comes along has to be able to explain the world we already observe, right? And a massive part of that world is governed by this quantum property called spin. So what on earth makes spin so strange, and why is it such a do-or-die test for this new model?
It all boils down to this one little number. See, the fundamental particles that make up matter, like electrons, they're called fermions, and they have this thing called half-integer spin, a spin of 1/2. Now, this has nothing to do with a tiny ball spinning. It describes a kind of symmetry that is just, well, it's completely bonkers compared to anything we see in our everyday lives.
Okay, to really wrap your head around this, there's this fantastic analogy called the belt trick. Picture this. You're holding a belt, and one end is fixed in place. Now, you take your end and you rotate it a full 360 degrees. What happens? The belt is twisted, right? It's not back to how it started. But now, here's the magic. Rotate it another 360 degrees, so that's 720 in total, and poof, it's perfectly straight again. It's back to its original state. That, as weird as it sounds, is the reality for a particle like an electron. It has to turn around twice to get back to where it started.
And being able to replicate that exact behavior, well, according to the researchers themselves, that is the single most critical benchmark. It's the make-or-break moment. If their model of a single fabric can't naturally produce this bizarre 720-degree symmetry, then the whole theory just falls apart. It's that important.
So how in the world are they even going to try to do that? Well, their best shot is to see if they can create a specific, stable vibration within their fabric, something they call a resonance carrier ball, that basically has the geometry of that belt trick baked right into its structure. That resonance, that would be their version of a fundamental particle.
Okay, I know this all sounds super abstract, so how do you test it? I mean, you can't exactly go out into the universe and poke the fabric of reality with a stick. The answer? You build a digital one and run the experiments inside a computer.
And the plan they've laid out is actually pretty straightforward, a clear two-step process. Step 1, you build the fabric numerically. You create a stable digital model of this single elastic thing. Step 2, once you've got your mini-universe up and running, you create 2 of those special resonant shapes. They're stand-ins for fermions, and you smash them together to see what happens.
And this is the really important part. This whole approach takes the idea out of the realm of just, a cool philosophical concept and puts it squarely into the world of testable, rigorous science. A real scientific theory has to be falsifiable. There has to be a way to prove it wrong.
And this digital collision, that's the experiment designed to do exactly that.
Okay, so this brings us to the most exciting question of all. What if it works? I mean, what does success even look like here? And if this digital experiment pans out, what would it actually mean for how we see, well, everything?
And let me be clear, the bar for success here is incredibly high. The results of the simulation can't just be kinda close. They have to perfectly match the real world. For instance, when those two digital fermions collide, they absolutely must obey something called the Pauli exclusion principle. That's a fundamental law of nature that says two fermions can't occupy the same state, and it's a direct result of that weird half-integer spin. And all this quantum weirdness has to pop out naturally, just from the fabric's properties, with no cheating or extra rules tacked on.
So if, and it's a big if, but if the model actually passes this test, the payoff would be absolutely huge. It would instantly launch this two-layer model from being just a fascinating idea to what the researchers call a trustworthy theory. We're talking about a serious new contender for explaining the fundamental rules of our universe.
And that leaves us with one last, really profound thought to chew on. This whole model forces you to ask, is all the incredible, breathtaking complexity we see all around us, from the tiniest subatomic particles to the biggest galaxies, is it really a collection of countless different parts? Or could it all just be the intricate, vibrating behavior of one simple thing? Could our entire reality just be ripples in a universal fabric?